Hello everyone. On this video, I'm going to be discussing multiplication and division of decimals. But I'm only going to deal with relatively simple decimals, that is, decimals with only one or two decimal places. If we have a multiplication or division problem with more challenging decimals, that is, decimals with a lot of decimal places, like these, then we can handle it in the same manner I will be teaching you, but it will be messy, time-consuming, and error-prone. There is an area of arithmetic called scientific notation, which was devised for the specific purpose of handling calculations like this more easily and more effectively. I will be presenting a video discussing scientific notation after we complete our study of decimals and after we learn a little bit more about exponents. Let's get started with multiplication. Multiplying decimals is exactly like multiplying integers, except you have to keep track of the decimal point. Suppose I was multiplying 64 times 12. I understand that the way this type of multiplication problem is taught has changed over the years, but I'm going to use the old school style because, well, I went to an old school. However, the way you approach this problem is not important as long as you consistently get the right answer. So do this calculation in the way you are most comfortable. I do it like this. 2 times 4 is 8. 2 times 6 is 12. 1 times 4 is 4. 1 times 6 is 6. Bring down the 8. 2 plus 4 is 6. 1 plus 6 is 7. The answer is 768. Now imagine that I was multiplying the same digits, but involving decimals. Let's try 0.64 times 1.2. The multiplication is going to give me the same three digits for an answer, 768. But I have to count the total number of decimal places in the problem and insert the decimal point in that location. I have 2 decimal places in the first number and 1 decimal place in the second number for a total of 3 decimal places. My answer must have 3 decimal places. The correct answer is 0.768. Let's modify the problem just a little. Suppose that I want to multiply 6.4 times 1.2. Again, these are the same digits for both numbers as my first problem. So I have 768 as the 3 digits in the answer. I just have to figure out where to put the decimal point. Well, there is 1 decimal place in the first number and 1 decimal place in the second number for a total of 2 decimal places. I put 2 decimal places in the answer and I get 7.68. I am done. Try one yourself. After I give you the problem, please pause the video, work out the answer, and then resume the video. What is 0.15 times 0.3? Please pause the video now. Let's work this out. Ignoring the decimal places for a moment, we have 15 times 3, which is 45. Now let's figure out where the decimal point goes. 0.15 has 2 decimal places, and 0.3 has 1 decimal place, for a total of 3 decimal places. In order for us to get 3 decimal places, we have to add a 0 to the left of the 4, and then put the decimal point to the left of that 0. The answer is 0.045. As an aside, I often get asked if it's okay to omit the 0 in the ones place and just write 0.045. Technically, the answers are the same, but from a standpoint of communicating clearly and unambiguously, it is important to include the 0. If we left the 0 out, it would be too easy to overlook the decimal point or to assume that it is a period or even just an inadvertent pen, pencil, or chalk mark. So I always include the leading 0 when I want to express a decimal with a magnitude of less than 1. Let's do some division problems, and then we will be done with this lesson.
Hello, darling.
Is this the Decimal Diva again?
Of course, darling. How do you like my musique d'entrée? I think it is quite dramatic.
It's dramatic, all right. You chose The Ride of the Valkyries?
It's a little something that Ricky wrote for me years ago.
Ricky? Do you mean Richard Wagner?
Ricky and I spent many glorious days at his little chateau outside of Leipzig. I was his muse, you know.
His muse?
Ricky would braid my hair, and I would put on my helmet with the marvelous horns and my silver breastplate. I was his favorite shield maiden. He was so bold, so impetuous, and so Teutonic.
Okay, well, I think that's a little too much information for me. I have to get back to work.
Toodaloo, darling.
Toodaloo. So where were we? Oh yes, division of decimals. Like multiplication, division using decimals is similar to division using integers except for the additional task of keeping track of the decimal point. Let's try a problem. What is 2.7 divided by 0.3? Before I tackle this problem, I want to bring up two important points, the second of which is a little esoteric, so please bear with me for a moment. I'm going to do one thing a little bit differently than I have in the past videos. I have been using this notation for a division sign. It is what we learned when we started arithmetic, but now I'm going to start representing the division problems in a fractional form. That is, I'm going to put the number we are dividing, remember that it is called a dividend, in the numerator, and I'm going to put the number we are dividing by, the divisor, in the denominator. Recall that the result of the division problem is called the quotient. This is not a common fraction, as we have been studying, since a common fraction has integers in both the numerator and denominator. But it is perfectly acceptable to express a division problem in this manner. In fact, all of the other branches of mathematics outside of arithmetic use this notation to represent division, rather than using the division sign we have been using. We need to become familiar with the notation. The advantage of representing a division problem in the form of a fraction is that it really ties the two concepts together. A fraction is really a division problem. Here comes the more esoteric part. A problem like this is just an expression. In this case, our expression is two numbers and the operation of division which is being performed on these two numbers. When I solve a problem like this, all I am doing is putting the expression into the simplest form possible. But this simplest form must be equivalent to the original expression that I defined. We need to use operations like addition, subtraction, multiplication, and division to put expressions in their simplest form. But we are only allowed to perform operations which give us a result which is equivalent to the original expression. I bring this up because a quite common mistake, perhaps the most common mistake, that math students make is that, in attempting to put the expression in its simplest form, they perform some operation which no longer makes the answer equal to the original expression. Let me give you my best math instructor who is also a grandpa analogy. Grandma makes some chocolate chip cookies, and so, wanting to earn some grandpa points, I take 2 of them fresh out of the oven and offer them to my granddaughters. As long as the cookies are the same size and have the same number of chocolate chips, everything is great. The cookies are equal to each other, as far as my granddaughters are concerned, and I'm on my way to earning 10 well-deserved grandpa points. But before my granddaughters eat their cookies, one of them looks at me with her big granddaughter eyes and says, "You know, sometimes Grandma puts some sprinkles on the cookies for us." I start to think, maybe I can earn a few more grandpa points, maybe get 12 or even 15 instead of just 10, if I put some sprinkles on the cookies. So I take the still warm cookies back to the kitchen and put on some sprinkles. One of the cookies has a lot of sprinkles on it, but when I start to fix up the other cookie, I run out of sprinkles, so there are only a few on the second cookie. I figure that both cookies have been improved by me by adding the sprinkles, so I take them back to my granddaughters and expect both of them to greet me with grateful smiles. This is a warning for all of you prospective parents and grandparents out there. Do not try this at home. It does not work. You may very well end up with a nasty argument on your hands as your grandchildren fight over the 2 cookies. When grandchildren fight, Grandma gets involved, and when Grandma gets involved, you lose all of your well-earned grandpa points. It is the oldest grandpa mistake in the book. What has happened mathematically is that I have taken 2 things which are equal to each other, that is, the cookies, and I have performed an operation on them, that is, put on sprinkles. But I have transformed the cookies by that operation into 2 things that are no longer equal. It is a mistake in math and a mistake in grandparenting. Let's start to work on this problem and see how my grandpa story fits in. We start by making the divisor, that is, the denominator, into an integer. In this case, in order to do this, I can simply multiply the divisor by 10. In doing so, 0.3 becomes 3. But if I multiply the divisor by 10, I must also multiply the dividend, that is, the numerator, by 10. If I don't take this latter step, I have changed the original problem and I won't get the right answer. I will have added sprinkles to one cookie and not the other. If I multiply both the numerator and denominator by 10, I will not have changed the resulting quotient. By multiplying both the numerator and denominator by 10, I have performed an operation which is a step towards putting the expression in the simplest form while keeping the problem equivalent to what it was. In fact, what I have done is multiply the original fraction by 1 as expressed in its equivalent form of 10 over 10. 1 is the multiplicative identity, and so I can multiply any number by 1, or any expression equivalent to 1, without changing the value of the number. My action of multiplying both the numerator and denominator by 10 has the effect of moving the decimal point one place over to the right for both decimals, that is, changing both the numerator and denominator into integers. My problem is now 27 divided by 3. The answer is 9. Let's try another division problem. What is 3.6 divided by 0.02? Again, the approach is to convert the denominator into an integer. I do this by moving the decimal point over 2 places. That is equivalent to multiplying the denominator by 100. Having done so, I must also multiply the numerator by 100, so that the resultant expression remains equivalent to the original. This will have the effect of moving the decimal point in the numerator 2 places to the right. I must add a 0 on the right of 3.6 in order for me to be able to move the decimal point over by 2 places. My division problem is now 360 over 2. The answer is 180. I am done. Last problem. Please try this on your own. As always, pause the video after I give you the problem and then resume it when you have the answer. What is 0.6 divided by 0.15? Please pause the video now. Let's work this out. First, we need to change the denominator to an integer. That means moving the decimal point over 2 places to the right. This is equivalent to multiplying the denominator by 100, but if you have done enough of these problems, you become comfortable with simply moving the decimal point over 2 places with the understanding that you must also move the decimal point in the numerator 2 places to the right. In order to move the decimal point in the numerator 2 places to the right, I must add a 0 to the right of the 6. Our problem is now 60 divided by 15. The answer is 4. How did you do?
I'm learning so much.
Good. In the last 2 videos, we have gone through the main arithmetic operations of addition, subtraction, multiplication, and division of decimals. There are 2 main areas that still need to be covered, and we will tackle them in our next 2 videos. Decimals have not completely replaced common fractions in arithmetic because, just as there are some weaknesses in the use of common fractions, there are some weaknesses in the use of decimals. We will practice converting fractions into decimals and talk about converting decimals into fractions and the problems that are sometimes associated with that latter operation. Lastly, we will talk about 2 types of errors, a rounding error and an iterative error, which comes about from using decimals in places where common fractions are better suited. We are done. You know, I think I'll try to punch up my musique de sortie a little bit. Have a good day.
We hope to see you at Veterans Upward Bound very soon and recommend a friend.